Hello, I am going to be going over Chem 102, Exam 2, how to solve these questions. So, first and foremost, this one is regarding a student who recorded the same initial temperature of two solutions prior to mixing them. He had a mass of 131 grams, a specific heat capacity of 4.18 joules per grams degrees Celsius, and a final temperature of 29.2. 12.9 kilojoules of energy was released as heat when the solutions were mixed there, and we want to find the final temperature. So immediately I'm going to convert 12.9 kilojoules into joules by multiplying by 1,000. So 12.9 kilojoules times 1,000 joules equals 12,900 joules. Then I'm going to plug that in as my Q. Then I'm given that the mass is 131 grams, so I'm going to put that there. I'm given that the specific heat is 4.18, so I'll put that there. And I am given that the T final of my delta T is 29.2, and I'm solving for the initial, which I'm going to write as X. So the first thing I'm going to do is I'm going to divide both sides by 131 and 4.18. And then that is going to give me 23.558 equals 29.2 minus X. So then I'm going to add X to both sides and then subtract 23.558 from both sides. To get 5.64 degrees Celsius for my T initial, giving us 5.64 as our answer. The next is a 3-liter flask containing 2.15 grams of helium gas, a molar mass of 4.003 grams per mole, separated by a stopcock from a 3-liter flask containing 3.06 grams of fluorine gas, 38 grams per mole. The stopcock is opened and the total pressure is 631 mercury. The temperature remains the same after the stopcock is opened. What was the pressure of the helium before the stopcock was opened? So first, what I like to do is set up an open and closed system and then determine what I am given as a variable and as a constant in said systems. So in the open system, I am given the moles, the volume, the pressure, and the constant, and I don't have T. In the closed system, I don't have P, I don't have T, I don't have N, or I have N, I have V, and I have R. So, because after the stopcock is open, the total pressure is, I apologize, I underlined the wrong thing. Because after the stopcock is open, the temperature remains the same. That means this T is equal to this T. I can solve for the T of the open system. So I'm going to do my pressure for open equals 631 divided by 760, which is equal to pardon me, 0.8303 ATM. Then my volume open is equal to 3 liters plus 3 liters, which is 6 liters total. My N open is equal to 2.15 grams over 4.003 grams helium plus 3.06 grams divided by 38 grams of fluorine, which is equal to, I believe it is equal to 0.6176 moles. And then I know R is equal to 0.08206. So then I'm going to set up my equation. I know PV equals nRT. I know my pressure is 0.8303 times my volume, which is 6, equals 0.6176 times 0.08206 times T. Now I'm going to divide by 0.6176 times 0.08206 on both sides, which is going to give me T equals 98.29 degrees Celsius. I'm going to quickly erase this so we can work on that closed system now. So I'm going to quickly give this a quick wipe down because I am going to run out of room otherwise. Here's the number we solve for. So now I know that my moles of helium are equal to 0.5371. And I put Celsius earlier. I meant Kelvin, so that's my bad. I know my R is 0.08206. The reason that the moles are different is because this is before the stopcock is open. We're finding the pressure of helium, and so I am only including the moles of helium. I know that my volume is equal to 3 liters, because again, it's before the stopcock is open, and I'm solving for P. So I'm going to set my equation, P times 3 volume equals 0.5371 moles times 0.08206 times 98.29 Kelvin, which is equal to 4. P times 3 equals 4.332. Then I'm going to divide by the volume to get the pressure. P equals 1.444 ATM, but I'm not quite done yet because our question asked for it in mercury. So then I'm going to multiply 1.444 by 760, which is equal to 1097, which in scientific notation is 1.1 E3, giving us this answer. All right. Next, consider two gases D and E in separate 2-liter vessels at the same temperature and pressure. The mass of gas D is 0.8 grams and the mass of gas E is 0.98 grams. Which of the following statements, 1 through 4, concerning gases D and E are false? So the first thing we need to note is if they're in 2-liter vessels, we know that the volume of D equals the volume of E. If they're at the same temperature and pressure, we know that the pressure of D equals the pressure of E, and the temperature of D equals the temperature of E. This means that they must have the same moles. N equals NE, because in a 5-variable equation where PV equals nRT, where R is always constant, if T, V, and P match, N must match. So, the vessel containing gas E has more molecules present than the vessel containing gas D. We just established that the moles of gas D and the moles of gas E are equal. Because moles times Avogadro's number equals molecules, that cannot be possible. So number 1 is false. Both gas samples contain the same average kinetic energy. We know that kinetic energy's average is equal to 3/2 RT. R is a constant, which is 8.314, and we know that they're at the same temperature. Therefore, 2 must be true. Gas D moves at a faster average velocity than gas E molecules. So, we know that as the mass of a substance increases, the speed, or velocity in this case, of substance decreases due to the formula square root of 3RT over mass in kilograms equals velocity. Because they have differing grams and E is heavier, and the faster you are, the smaller you are, or the bigger you are, the slower you move, that means gas D must have a higher average velocity than gas E. So this one is true. Gas E hits the walls of the vessel more frequently than gas D. We just established that gas D moves faster than gas E. So therefore, gas D cannot, gas E cannot hit the walls more frequently if it is moving slower. So 4 is also false, which gives us 1 and 4 as our answer. Consider the following plot that shows the fraction of a sample of gas molecules that have been given a speed at the same temperature. The gases plotted are hydrogen, helium, nitrogen, oxygen, and water vapor. Which of the following plots below A to E correspond with hydrogen? So this is also referencing our velocity, where the bigger you are, the slower you move, because 3RT over mass in kilograms, the root of that is the root means of velocity. So we know hydrogen as a diatomic is going to be equal to approximately 0.002 kilograms. We know that helium is going to equal approximately 0.004 kilograms. We know that H2O is going to equal approximately 0.018 kilograms. We know that N2 is going to equal approximately 0.028 kilograms. And we know that O2 is going to equal approximately 0.032 kilograms. And I calculated all of these using the molar masses of each of the molecules. So, based on this, again, the bigger you are, the slower you move. As we can see, oxygen is our largest molecule, and therefore it is going to move the slowest at A. Nitrogen is our second largest molecule, moving second slowest at B. C is going to be H2O because that one is in the middle. Helium is going to be our second fastest, and hydrogen is going to be our fastest. So our answer is going to be C. Which of the following processes demonstrates work being done by the system? So we know that if work is being done by the system, work is being done by the system, that volume should increase because it is expanding, and work should be negative. So we're going to look for the moles, and we're going to be looking for increasing moles because increasing moles will increase volume. So here, and this only applies for in gaseous form. So if I had if I had 4 CO2, or no, we'll do 3. If I had 3 CO2 and I made it into 3 carbon solids and 2 ozone, which I doubt would ever happen, but the point stands, I would still be losing volume because solids do not count towards volume. So in this case, I have 1 gaseous molecule here, and this is solid, that's solid, so I have 0 here. So this one cannot be it, because this would have a negative delta V. 2NO gas plus O2 gas, so I have 3 over here, gives 2NO2. Nope, that one can't be it either because the change in volume also decreases. Then I have 3 NO2 gas plus H2O makes 2 HNO3 and NO gas. So I have 1 gas over here, I have 3 gas over here. Can't be this one either because this one also decreases in volume. Therefore, none of the processes given demonstrate work being done by the system. A system fitted with a piston expands when it absorbs 52.1 joules of heat from the surroundings. The piston is working against an external pressure of 0.501 atmospheres. The final volume is 62.4 liters. What is the initial volume of the system if the internal energy of the system decreases by 111.7 joules? So first we're going to set up our delta E equals Q plus W equation. So I know that I lose 111.7 joules during the reaction. I also know that it absorbs 52.1 joules, so that means that my Q is positive. Then I also need to use the equation negative P external, so negative 5.501 ATM equals V final, which is 62.4 minus V initial, which we're going to annotate as X. So the first thing I'm going to do is subtract 52.1 from both sides so I can get the joules of work done by itself. So that is going to give me that is going to give me 163.8 joules equals negative 0.501 times 62.4 minus X. The next thing I'm going to do, because this is going to end up being in ATM times liters in terms of units, is convert my joules to units of liters times atmospheres. So I'm going to divide by 101.3. That looks like a 7. That is actually meant to be a 1. 101.3. So I'm going to divide, and that's going to give me 1.6198 liters atmosphere equals negative 0.501 times 62.4 minus X. So then I'm going to divide by my negative P external. Oh, I forgot my sign here. I'm in trouble. Divide by my negative P external, which is going to give me my change in volume. So my delta V is equal to 3.2275. So 3.2275 equals 62.4 minus X. I'm going to add X to both sides and subtract 3.2275 from both sides. And then that is going to give me 59.2 liters as my answer. Consider the following unbalanced equation for the reaction P4 solid plus fluorine gas equals PF3 gas. Balance the equation and use the correct balance equation to answer the following question. What mass of reactant in grams would remain unreacted if 137 grams of P4 and 89.8 grams of F2 react? So I know I have 137. Let's start with balancing the equation, actually. So I have P4 plus F2 makes PF3. Now, I know that I have, in terms of raw material, 4P on this side, 2F, and then 1P on this side, and 3F. In order to make these balanced, I know I need 4P on this side, so I'm going to make this a 4. And then that 4 times 3 gives me 12. 12 divided by 2 gives me 6. So that is my balanced equation. So the next thing I'm going to do is I'm going to convert 137 grams of P4 into moles of P4, which is going to give me 1.1059 moles P4. And then I'm going to do the same with my F2, 89.8 grams F2 times 1 mole over 38 grams equals 2.363 moles of F2. So the next thing I'm going to do is I'm going to convert both of them to products, which in this case is PF3. So I have 1.106 moles of P4. For every mole of P4, I can make 4 moles of PF3. Which equals 4.424 moles of PF3. And then I'm going to do the same for fluorine. I have 2.3632 or 2.363 moles of fluorine, and for every 4 moles of PF3 that I can make, I need to use 6 moles of F2. And so the moles times the ratio of 4 divided by 6 gives me 1.575 moles of PF3. So F2 is our limiting reactant, so I'm going to subtract the possible product producible by P4 minus the limiting reactant product possible to get the remaining amount that won't be used. So that gives me 2.848 moles of PF3 that could have been made. So then I'm going to convert 2.848 moles of PF3 back to moles of back to moles of P4, which is going to give me 0.712 moles, which multiplied by the molar mass of 123.88 grams equals 88.2 grams remaining as our answer. What volume of water in milliliters must you add to 63.9 milliliters of 0.776 molar cobalt chloride in order to form a solution with chloride minus ions with a concentration of 0.161 molar? So the first thing I'm going to do is I'm given 0.776 molar of cobalt chloride, and I know I need 2 chloride because the 2 here indicates that cobalt has a 2+ charge, chlorine has a minus charge, and therefore I need 2 to balance it. And then I know that I have, in terms of liters, 63.9 milliliters over 1,000 liters. And I want to know the moles of cobalt chloride. So then I'm going to multiply both sides by 0.0639, which is the liters. Multiply by 0.063. 0.0639. And then that is going to give me 0.0495. I forgot the 9. Let's try that again. 495 9 moles of COCl2. Now, I want the Cl minus, so I need to do a little conversion here. 0.04959 moles of cobalt chloride times 2 chloride ions over 1 cobalt chloride equals 0.0991728 moles chloride. So then I need to find the milliliters. So I know that 0.161 molar Cl minus is what I'm looking for. And then I need to bring my moles down here, which gives me 0.0991728 moles Cl minus divided by X liters. So I'm going to multiply both sides by X and divide both sides by 0.161 molar chloride. which is going to give me in liters 0.61598 liters. Then I need to multiply by 1,000 to get milliliters, which is 615.98 milliliters. However, I am not done yet. It asks how much must you add to 63.9 milliliters. So I need to subtract 63.9 milliliters to get my final answer, which is going to be 552. Sorry, is going to be 552 milliliters as our answer. All right, a hydrogen bond is normally depicted between molecules using dashed lines. Which of the following diagrams does not show hydrogen bond between molecules? Now, before we even start this question, I'm going to remind you, a hydrogen must be bonded, so coming off of in any molecule, a nitrogen, like so, connecting to a nitrogen, oxygen, or fluorine, a oxygen connected to a hydrogen, which forms a hydrogen bond between nitrogen, oxygen, or fluorine, or a fluorine connected to a hydrogen bonding to a nitrogen, oxygen, or fluorine. So with that in mind, we're going to take a look at these. Now, the very first one here is our hydrogen. Automatically, I know this cannot be a hydrogen bond because it's connected to a carbon. So the first one isn't it. The second one, I'm going to look at my hydrogen. I can automatically see it's connected to a carbon, so I know it can't be number 2. The third one, here's my hydrogen. It's connected to an oxygen. So this one, hydrogen bond, because it's connected to an oxygen and it's bonding to an oxygen. And the fourth one, here's my hydrogen. This one doesn't work either because there's a carbon. It's connecting through a carbon, therefore it can't be a hydrogen bond. So 3 is the only one that does show hydrogen bonding. So we're looking for one that says 1, 2, and 4, which is right here. And that's our answer. Skeletal structure of 3-butanoic acid is shown below. How many atoms are present in 40.7 grams of 3-butanoic acid? So first let's draw our structure from the carbon structure. So I'm going to add in my carbons, and then I'm going to add in my hydrogens. And one goes there, one goes there, and that's it. Okay, so that's done. The next thing I'm going to do is I'm going to immediately convert 40.7 grams into moles. So I'm just going to divide by the molar mass of 86.088. Let me do that very quickly. 40.7 divided by 86.088 is going to be 0.472 moles. So the next thing is I want to know the moles of hydrogen in this molecule because it's asking for the number of hydrogen atoms present, not the number of butanoic acid present. So I need to count how many hydrogen are in this molecule. 1, 2, 3, 4, 5, 6. So I'm going to multiply by 6 hydrogen per 1 butanoic acid, which is going to equal 2.837 moles. However, this is asking for atoms. So I need to multiply by Avogadro's number to get the atoms of hydrogen. So I'm going to multiply by, oh my goodness, I cannot speak today. I'm going to multiply by 6.022 times 10 to the 23rd. Over 1 mole, which is going to give me 1.71 E24 atoms as my answer. All right, which one of the following statement or the compounds, which of the statements is true? So it's essentially saying compound 1 is electrically conductive, compound 2 is electrically conductive, compound 3 is electrically conductive, all of them are or none of them are. So what we know about electrically conductive solutions, it simply means they're soluble. So let's look at zinc chloride first. According to our solubility rules, most chlorides, bromides, iodides are soluble except for silver, lead, and mercury. Zinc is not silver, lead, or mercury, so this one is soluble in water. The next one is a sulfate. It says most sulfates are soluble except those of barium, lead, calcium, and mercury. Iron is not barium, lead, calcium, or mercury, so this one, all good as well. Zinc bromide, again, back to this one. Chlorine, bromide, iodine are soluble except for silver, lead, and mercury. Zinc is not silver, lead, or mercury, so this one's perfectly fine just as well. So all of them are soluble, so that means all of them are electrically conductive. So our answer is going to be all of the given compounds. All right. An element has 4 major isotopes numbered 1 to 4 in the table below. The natural abundance of the elements of each is given. What is the element? So the first thing that we're going to do is we're going to set up our equation in terms of the proportion of molecules with the atomic mass measured times the atomic mass. So it's going to look like 0.0019 times 135.9014 or 907. Oh my goodness, 90714 plus 0.0025 times 137.90599 plus 0.8843 times 139.90543 plus 0.1113 times 141.9. I don't know why I wrote a colon. Let's try that again. 141.90924, which is going to give you an average AMU of 140.1159. Which, if you check your periodic table, is going to give you Ce as your element. What is the net ionic equation when aqueous solution of strontium chloride and iron nitrate react? So we know that according to our solubility rules, NO3 is soluble, no matter what. So that means that strontium has to be soluble because strontium chloride's already soluble, that's given. And it can't, if it's switching to NO3, it's still going to be soluble. And we remember from one of the previous questions, chloride is soluble in almost everything except for silver, lead, and mercury. Because iron isn't silver, lead, or mercury, that means our iron is going to be soluble as a 3+ molecule. So this one's soluble, this one's soluble. And that means that our chlorine minus are going to be soluble. Therefore, they are all soluble. If all of them are soluble, then no reaction occurs because they are simply ions floating in a solution. They're not joining with each other. And so, therefore, no reaction will occur. Rank the following in increasing vapor pressure. Okay, so vapor pressure, if the pressure of the vapor is high, that means that more of the substance is evaporating. If more of the substance is evaporating, it has a lower boiling point. If it has a lower boiling point, it has weaker intermolecular forces. So, if it's in increasing order, the first, second, etc., the first one should be the strongest intermolecular force. Now we'll remember ion dipole is our strongest. So I'm going to check first to see if there's an ion dipole. Fluorine to fluorine isn't an ion dipole. Hydrogen to fluorine isn't an ion dipole. Neither is hydrogen to bromine, bromine to bromine. Lithium to fluorine is. Lithium is a group 1 metal, and it has a positive charge. Therefore, this should be our first in the group. So I'm going to knock out H, F, F, F for these. These are all wrong. We already know this. So the next one that should come is hydrogen bonds. Fluorine to fluorine isn't a hydrogen bond. Hydrogen to fluorine is, because hydrogen's attached to a fluorine, and so that one works as a hydrogen bond, but both of those have HF next, so that's kind of a null point. The next should be dipole bonds. Hydrogen bromine is a dipole bond because one is much smaller and one is much larger, and therefore there is a dipole movement. So that one should be next, and both of them have that as next. The next is London dispersion forces. The higher the amount of electrons, the stronger the London dispersion forces. So, because I know fluorine, bromine, and CF4 all have London dispersion forces, and nothing else because they're all nonpolar, I'm simply going to add their electrons together. I know fluorine has 9, and so 9 times 2 is 18 electrons. I know that in regards to fluorine gas, I know that carbon has 6 plus 9 times 4 gives me 42 electrons in regards to CF4. And then bromine has 35 times 2, which is 70 electrons in regards to Br2. Therefore, Br2 should be our next on the list, making this one our answer. And last but not least, which of the following statements is or false for the changes in a system where Q equals 20 kilojoules and W equals negative 15 kilojoules? The first one states it is an exothermic reaction. We know this is false because Q is positive. If Q is positive, that means energy is absorbed. And if energy is absorbed, then it is endothermic. So the first one's wrong. We know that. The surroundings do work on the system. For the surroundings to do work on the system would need to compress. For the system to compress, the delta V would have to be negative. For the delta V to be negative, the work would have to be positive. Work is not positive here. Therefore, we know this one is wrong. Delta E equals 35 kilojoules. Q plus W equals delta E. We know that Q is 20 kilojoules. We know that W is negative 15, which gives us 5, not 35 kilojoules. So 3 is wrong. Heat flows from the surroundings to the system. Energy is absorbed by the system according to the positive Q, and so that means it is taking in energy, so number 4 is correct. The volume of the system increases. For work to decrease, for work to be negative, delta V needs to be positive, and therefore V final must be larger than V initial, and therefore it must expand. If it expands, the volume would increase. So 4 and 5 are correct. This question asks for which is false, so that means 1, 2, and 3 are incorrect. I hope that some of these review questions helped, and best of luck if you are retaking. Thank you.